Reviewing the LCM and equivalent fractions. Least common multiple. The least common multiple, or LCM, of two natural numbers is the smallest number that is a multiple of both numbers. Example, find the LCM of 6 and 8. Okay, let's first create a partial list of multiples for 6 and 8. So multiples of 6 would be 6, 12, 18. Basically, we're just multiplying 6 by each natural number starting at 1. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18, etc. Or if you keep adding by 6. And the same thing with 8. 8, 16, 24. Now the LCM is the smallest number that appears in both lists. So it's a common multiple. Not just a common multiple, but the lowest common multiple, or the least common multiple. So which is the smallest number that appears on both of those lists? Yeah, that's right, 24. So 24 is the LCM of 6 and 8. Okay, now why are we reviewing least common multiple right now? Because we're getting prepared to add fractions. And part of the process of adding fractions is finding the lowest common multiple. Then we're also going to talk about equivalent fractions. And that's also part of the process of adding fractions. Okay, there are other common multiples, such as 48 and 72. So you notice that on this list, 48 is on both of these lists, as well as 72. And if we kept going, there's going to be others. But when we add fractions, we're going to have to find the lowest common multiple, or we'll call it the lowest common denominator. And we want the smallest one because that will make it easier so that we won't have to reduce the fraction as much at the end. Okay, let's keep going. Let's just find the LCM of 10 and 12, and we'll use the same method. But we have another method that we're going to talk about in just a little bit. So let's find a list of common multiples. So there's 10, 20, 30, etc. And just keep going until you find the first one that appears on both. Find the first number that's a common multiple for both 10 and 12. And we see what that answer is, right? That's right, 60. So the LCM of 10 and 12 is 60. Okay. So what I wrote here is find the LCM as a process to adding and subtracting fractions with unlike denominators. So it's very important. We're not going to be able to add fractions or subtract fractions unless we know how to find this LCM. So this was an okay method as long as the numbers are relatively small. But what if you have to find the LCM of 84 and 90? Then making a list of multiples until we find a common multiple, that's going to take some time, quite a bit of time. I believe the LCM of 84 and 90 is like 1,260, so it's going to take a while to get to 1,260 by listing all the multiples. Fortunately, we have a better method. We have a proper process. And this process will also make it easier when we make the transition to algebra. Okay. Step 1. Find the prime factorization of each number. The tree, or the division method, whichever method you like to use. But that's our first step, the prime factorization. And then step 2, this is a little bit of a tricky step. Identify the prime numbers. The LCM is a product of these prime numbers using each prime number the greatest number of times that it occurs in any one of the prime factorizations. This product is the LCM. Yeah, that sentence is kind of tricky. using each prime number the greatest number of times that it occurs in any one of the prime factorizations. Okay, so you might want to pause the video, write these notes down, once you already have it in your book. Maybe you might want to highlight it in your book. And then we'll go on to do some examples. Okay. Find the LCM of 15 and 24. So we're not going to list the multiples. We could, but we want to use a better process. So step 1. Find the prime factorization of each number. So do the tree. Let's see, 15, 3 times 5, 24, 4 times 6. 4 is not a prime number, so we could break down the 4 to 2 times 2, and 6 is 2 times 3. But I'd always like to list it in a row form. So 15 is 3 times 5, 24 is 2 times 2 times 2 times 3. If I go too fast, make sure you just pause the video and keep writing until you've caught up. Okay. Write LCM below the factorization of each number. So underneath that 24, just write LCM equals. Okay. Now this is the tricky part. Consider each prime number. Write it the greatest number of times it occurs in one factorization. So start with the number 2. What's the greatest number of times it occurs in any one row? That's right, 3 times. So write down 3 2's. 2 times 2 times 2. Okay, the next is the number 3. Write it down the greatest number of times that it occurs in any one factorization, in any one row. How many times does the 3 occur in the 15? Just once. How many times does it occur in the 24? Just once. So what was the greatest number of times that it occurred in either row? Just once. You're not adding both of them. You're just saying what's the most number of times that it occurs in one row. So the 3, it occurs once. So we'll multiply another 3 to the LCM. And now the number 5. What's the greatest number of times that it occurs in any one row? That is once. So we'll multiply that all out, and that'll give you your LCM. You go in order. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And then 24 times 5 gives you 120. Or you could group it in any manner. You can multiply the first 3 numbers and the last 2 numbers. Or you could, what I like to do is find a 10. See, 2 times 5 is 10. So that's the first 2 and the last 5. And then the 2 other 2's that I didn't use in the 3, that gives you a 12. So 12 times 10 would be 120. So you could go in any order. Okay, let's do another one. Let's take some time. Find the LCM of 14 and 20. Maybe you might want to pause the video, work this one out on your own, and then click on play when you're ready to start. Okay, step 1. Find the prime factorization. The tree. "14 is 2 times 7. 20 is 4 times 5, but 4 is 2 times 2. Okay, now write it down in a row, in row format. Okay, here we go. This is the good part. Right, LCM equals, and now we're going to consider each prime number and write it the greatest number of times that it occurs in one factorization. So the number 2, what's the most times that it appears in one row? Twice, right? It appears in that second row twice. The first row only once, but the second row twice. So we will have 2 2s. Next is the 5. What's the greatest number of times the 5 occurs? Once. And 7, once. We'll multiply that out, and that will be your LCM. Two times 2 is 4. 4 times 5 is 20. 20 times 7 is 120. Did I say 120? I meant 140. Sorry about that. 2 times 2 is 4. 4 times 5 is 20. 20 times 7 is 140. Well, if you multiply a 2 and a 5, that's 10. And then 2 times 7 is 14, so 14 times 10 will be 140. Okay, let's do another example. Okay, this one has 3 numbers, 12, 30, and 70. So number 1, we're going to find the prime factorization of each number. So we're going to do the tree for all 3 numbers. Twelve is 2 times 6, and 6 is 2 times 3. Now we'll do the 30 next. Five times 6, and then again 6 is 2 times 3. And then 70 is 7 times 10. 10 is 2 times 5. Now we'll write it in a row format. Remember, if I'm going too fast, just pause, catch up, and then click back on play. Okay. Now we're going to write the LCM below that. LCM equals. And then here's the fun part. Consider each prime number. Write it the greatest number of times it occurs in any one row. So the number 2. What's the greatest number of times that it occurs in one row, and one row only? Twice, right? It occurs twice in the top row. There's 2 2s in the 12. Now the 3. What's the greatest number of times the 3 occurs? Just once. It occurs once in the 12 and once in the prime factorization of 30, so it'll just be once. Now the 5. What's the greatest number of times it occurs? Just once. And then the 7, again once. Now we'll multiply that out, and that will be your LCM. See, I might think of a 2 times 5, that's a 10. And the other numbers is 2 times 3 times 7, so 6 times 7 is 42. 42 times 10 is 420. Okay, we'll move on. Equivalent fractions. Recall the multiplicative identity. It's also called the multiplication property of 1. Probably because a lot of people can't say multiplicative, so then they just say, well, let's just change the name to multiplication property of 1. If you multiply any number by 1, what do you get? You get the same number, a. So a times 1 equals a. Example, 5 times 1 is equal to 5. Now remember that any fraction with the same numerator and denominator, except for 0, is equal to 1. So 0 over 0, in a previous video we said that that was called indeterminate. 0 over 0 is called indeterminate. But any other number over itself is equal to 1. 3 over 3 is 1. 5 over 5 is 1. 5,278 over 5,278 is 1. So if we take a fraction, like 1/2, and we multiply it by 1, we get the same number. So 1/2 times 3 over 3, multiplying straight across, that gives you 3 over 6. It's the same number, it's called an equivalent fraction. It looks a little bit different. It's like this is really the opposite of reducing. And why are we doing this? Again, we're getting ready to add and subtract fractions, and we're going to have to make the denominators the same. So when we change the denominator, we're going to have to change the numerator. So you might remember, oh, if I'm multiplying the bottom number by a number, I got to multiply the top number by the same number. And that's because it's equal to 1. So 1/2 times 5 over 5 is equal to 5/10, which is still the same number, 1/2. They just look different. They're called equivalent fractions. So 1/2, 3 over 6, and 5 over 10 are all called equivalent fractions because they have the same value. Think about a percent. If you got 1 out of 2 right, you got 50%, right? 3 out of 6, 50%. 5 out of 10, 50%. The fraction most simplified is 1/2. Okay, let's go on. Write the following fractions as an equivalent fraction with a given denominator. So we already have a fraction, like our first one is 3/8, but we want the denominator to be equal to 40. I wrote it below again. We'll put a little notes in between. Leave a little space on your paper when you're working these kind of problems out, because you're going to have a number that you multiply by to make it that new denominator. So the question is, what number multiplied by 8 will give 40? So our old denominator is 8. We want to multiply it by a number that makes it equal to 40. Or you could simply divide 40 by 8. What does that give us? 5. So now we are going to multiply the numerator and denominator by 5 to obtain the desired equivalent fraction. So multiply both top and bottom by 5. And what does that give the new numerator as? 15. So that's our answer. We don't want to reduce that because then we'll start back at the same number we had, 3/8. Let's go on to the next one. Again, our answer is just 15 over 40. It's all done. Okay, same thing with the next one. 2/9 equals what over 27? We want an equivalent fraction with a denominator of 27. What number multiplied by 9 will give 27? Or we could divide 27 by 9. So in this case, the new denominator, it's not that big, but let's say it was 8,145. Well, I don't know 9 times what number will give me 8,145, so I would just divide 9 into 8,145. Okay, so in this case our answer is 3. Multiply the numerator and denominator by 3. So whatever you multiply on the bottom, you got to multiply on the top. That gives you 6 over 27, and that is our answer. 6 over 27. Alright, let's move on. This will be our last example in this video. Remember that anytime you have a whole number, you can put a 1 underneath it. So 7 is the same as 7 over 1. So what number multiplied by 1 will give 3? Yeah, that's right, 3. So multiply numerator and denominator by 3 to obtain the desired equivalent fraction. So 21/3 is our answer. Okay, let's move on to the next one. We want an equivalent fraction with a denominator of 5, so what are we going to multiply it by? That's right, 5. Multiply numerator and denominator both by 5. So 12 times 5 is 60. Okay, that was the end of this video. I'll see you here for the next one. Have a good day.